Scientific perspectives on lion attack dynamics. Attacks by lions are a defining feature of African savanna ecosystems. They regulate herbivore numbers, maintain ecological balance, and serve as a critical focus of predator-prey research. By analyzing attack patterns, scientists gain valuable insights into evolution, biomechanics, and predator social structures. Sensory triggers for attacks. Lions initiate attacks using their acute senses, vision, adapted for low-light hunting, allowing effective nocturnal attacks. Hearing, sensitive enough to detect prey movements at significant distances. Smell, used less during attack but crucial for locating potential prey trails. These senses combine to maximize ambush success. Attack strategies in different environments. Open grasslands. In areas like the Serengeti, lions use vegetation cover and darkness to ambush. Wide visibility makes stalking difficult, so group coordination becomes critical. Woodlands and bushes. Here, cover allows closer approaches. Attacks may occur in shorter bursts, reducing prey's chance of escape. Near water sources. Prey often congregates near water. Lions exploit this by lying in wait along trails leading to rivers or ponds, initiating sudden ambushes. Energetic costs of attacks. Scientific analysis emphasizes that hunting is energetically expensive. A failed attack costs calories, increases fatigue, and may lead to injury. For this reason, lions frequently scavenge. Studies show that up to 40% of a lion's diet can come from scavenged kills, reducing the need for constant attacks. Success and failure rates. Data collected in Serengeti National Park reveals that only 25 to 30% of hunts result in a kill. Success rates rise when attacking at night or in cooler temperatures. Group size directly affects outcome, with prides of 5 to 7 hunters achieving the highest efficiency. Failure, however, is more common than success. Many prey animals have evolved counter-strategies such as herd defense, alarm calls, and high-endurance running. Physiology of an attack. During the final moments of an attack, several physiological mechanisms are at play. Muscle power. Lions rely on explosive type 2 muscle fibers for short bursts. Respiratory demand. Short, intense exertion pushes oxygen demand to maximum capacity. Adrenaline response. Both predator and prey experience stress-induced surges, heightening reaction speed. Intraspecific attacks among lions. Not all attacks target prey. Intrapride aggression is significant. Male takeovers, rival males attack to seize pride control, often resulting in deaths. Infanticide, new males attack and kill cubs to bring females into estrus. Food competition, aggressive swipes and bites occur during feeding, especially around large carcasses. These attacks reflect social hierarchies and reproductive strategies. Ecological importance of lion attacks. By removing vulnerable individuals, lion attacks strengthen herbivore populations. This predation pressure prevents overgrazing and contributes to biodiversity. Without lion attacks, ecosystems risk imbalance, leading to vegetation loss and declines in smaller species. Human perspectives on lion attacks. While rare, attacks on humans remain a subject of study. Most occur in regions where natural prey is scarce or where human encroachment disrupts lion habitats. Understanding these events helps conservationists design better coexistence strategies. Lion attacks are not random acts of aggression but highly adapted survival mechanisms. They reflect the complexity of predator biology, energy economics, and social structure. Studying these attacks reveals not only how lions survive but also how they shape entire ecosystems through the power of predation.